Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about bilge keels. More specifically, I want to talk about how you work with them and the limitations of them in the ProteusDS ShipMo3D toolset. So we have 3 sample projects to look at. All of these can be downloaded from the ProteusDS.com website. We've got the generic frigate, the generic offshore supply vessel, and the generic fishing vessel. So the bilge keels in red here, they're a fantastic feature to be able to add to help with roll damping and keep ship motion under control. Underlying the hydrodynamics of these in the calculation process, it's important to know that the forces from these are calculated from empirical viscous equations that are evaluated as a force, and then they're added, and this force is added and incorporated into the equations of motion when solving the motion of the ship. So in other words, what it's not doing is it's not doing things like accounting for the impact of these appendages on the flow field around the body. It's not accounting for things like the interaction between the appendages and other features on the hull and things like that. It's not the ShipMo3D toolset's not a computational fluid dynamics program. It's a ship motion program. So what that means is you have to be a little bit mindful of how much complexity you want to add into your bilge keels. It's great having bilge keels that are far away from other features on the hull. Obviously, the generic fishing vessel is a smaller vessel, and you don't have a lot of choice in how far away you are from other hull features like the keel there. But definitely you don't want to have other appendages nearby. In reality, they would interfere with each other and would reduce the performance, and you wouldn't necessarily get as meaningful or accurate output from a ship motion calculation. Similarly, the bilge keel that you add that's the geometry that you should add. You shouldn't be adding other kinds of bilge keel geometry in here in the ship model to make things more complicated, or try to do a T shape or some other kind of more sophisticated shape. It's just meant to be doing a flat plate drag kind of calculation. The nice thing about the generic frigate is it's got a skeg here, and of course you can see the bilge keels are far from the skeg. So there won't be much interference in the hydrodynamic performance between those, so that's good. So again, it's just another example of keeping appendages away from each other in terms of trying to accurately evaluate the motion performance of the appendages. The other thing I want to point out too is the generic frigate and the fishing vessel all have more sort of curved and complicated hull forms. But then when we look at the offshore supply vessel, it's got a very nice simplistic shape. There's a chine here along which the bilge keel is laid. It's very straight. It's very easy to add. You might be tempted to have only 2 data points to specify the bilge keel all the way along the length. However, you do want to have a few data points along specifying the bilge keel along the span, and what I mean by that is when you go to the bilge keel here, you can see under Edit Bilge Keel for the generic offshore supply vessel, there's several points, even though the information is all the same, the location and whatnot. Now, the reason for that is that in the calculation process, the local velocity at each of those points is resolved when calculating the forces, the viscous forces and lift and everything from these bilge keels. So if you only have on the generic offshore supply vessel, if you only had one point here and another point here, it would only be evaluating the viscous forces at those 2 locations. And for a larger vessel, and it's also accounting for the relative particle velocities from wave motions. You want to make sure you have a few points along the span. So there's some limitations and some nuances to working with those kinds of hull appendages in the ProteusDS ShipMo3D toolset. And thank you for watching.